Before we start, a quick thought, a quick experiment. Stick your tongues out, just a little bit. All right, in the last 1 second, 305 billion neutrinos just passed through your tongue. If you took pennies and stacked them all the way up, they would reach from here to halfway to the moon. Now, what does that mean, and what's this mysterious particle? Well, to first understand that, you have to know what the most fundamental particle is. Are they molecules, atoms, quarks? To understand that, you have to understand the Standard Model. Now, if you look at this, these are all the fundamental particles that we currently know about. On the outer ring, we have fermions, or the matter particles that we commonly interact with. And on the inner ring, we have bosons, or the force carrier particles. Now, to better understand what a boson does, let's take the electromagnetic force, or the ones that quarks, or what protons and neutrons are made out of. So what happens then, let's say you have two negatively charged particles, and they repel. What happens is one shoots out a photon, which is caught by the other particle, and then they both get spread apart. So that's the basics behind repulsion and how forces work. But we want to focus on these 6 particles, which are called the leptons. More specifically, we want to focus on these 2, which are the neutrinos. The neutrinos interact with the weak force, not the electromagnetic force. So they can't interact with light, which is why we can't see them, and also why it makes them sort of hard to observe. So there's 3 lepton flavors. The smallest is the electron, which corresponds to the electron neutrino, then muon, which corresponds to the muon neutrino, and finally the tau, which corresponds to the tau neutrino. Each have varying sizes, with the tau being the biggest, but we'll be focusing on the electron and muon neutrino.
Yeah, so just a bit of a basic overview of what neutrinos are. I'm just going to give you some properties, and then we're going to talk more about exactly what they mean. So first of all the particles we're going to be talking about today are point-like particles.